So, what we're going to talk about today is when acids and bases react with one another and they undergo what is called an acid base reaction. So, the reason we're studying this is so that we can figure out how acids and bases react in terms of acid rain. When an acid reacts with a base, we say that it's undergoing what's called a neutralization reaction. Um, so, what's happening is an acid gives up its proton to a base, and basically they cancel each other out. So, our acid donates a proton to a base, and that's kind of the driving force of a neutralization reaction. So, in this case, I have hydrochloric acid and the acetate ion. Now, the hydrochloric acid molecule is an acid, of course, meaning it gives up a proton. And the acetate ion is a base, meaning it will accept the proton. I know that it's a base because it has a negative charge on it, meaning that it can accept a positively charged proton. So when they react, the proton is going to be donated to the negative charge, and they essentially turn into new things. We have a chloride ion, and we have what's called an acetic acid molecule. Now, this brings up the topic of conjugate bases. When once an acid donates a proton, it becomes what's called a conjugate base because it's essentially no longer an acid. It's already given up its proton. So that means that now, instead, it has the ability to accept a proton. So after giving a proton, the substance is able to accept a proton back, which is the definition of a base. So here I have the molecule phosphoric acid. We have three protons that can be given up, although we're only going to worry about the first one right now. And what happens is when an acid is put in water, it gives up that proton to be something separate and becomes an ion, a negatively charged ion, usually. And we call that the conjugate base because now the acid has turned into a base because of the neutralization reaction. On the other side of the coin, we have what's called a conjugate acid. A conjugate acid is once a base accepts a proton, it becomes a conjugate acid. And this is because it now has a proton that it could donate to something else. So it's analogous to me donating money to you that you can then donate to someone else. So a base becomes what is called a conjugate acid. So here I have the base ammonia, and I have a free-floating proton from an acid. I didn't specify which acid because it's not really important right now. Now, I know that ammonia is a base because it has an exposed pair of lone electrons, and they'll react to form a conjugate acid. So in this case, I know it's an acid because it has a positive charge and an extra hydrogen. And because it came from ammonia, it conjugated from the base, so it is now a conjugate acid. And that's essentially kind of the gist of conjugate acids and conjugate bases. During a neutralization reaction, one turns into the other. And that kind of helps explain what's going on with acid rain, as we'll talk about in a later video. So if you have any questions, please feel free to ask. Otherwise, I hope that you have a great day.